Okay, 6.74. You and your bicycle have combined mass 80 kilograms. Is that a proper sentence? Whatever. So mass M equals 80.0 kilograms. When you reach the base of a bridge, you are traveling along the round at 5 meters per second. So that means when I'm here, so this is a bridge, when I'm right at the base, no idea what the round means, but I expect that the velocity at this point is 5 meters per second. At the top of the bridge, you have climbed a vertical distance of 5.2 meters. So the height of the bridge, 5.2 meters. And slowed to 1.5 meters per second. So at the top of the bridge, I need a bigger dot. My velocity, say v final, is 1.5 meters per second. Jeez. Ugh. It gets wonky towards the edge of the screen. Ugh. What is going on? I wish I had an iPad. Buy me an iPad, you guys. Ugh. Whatever. Okay, where are we? Ignore work done by friction and any inefficiency in the bike or your legs. What is the total work done on you and your bicycle when you go from the base to the top of the bridge? Alright, so remember, total work done on the system, and the system is me and the bicycle, is equal to the change in the kinetic energy. Well, we don't know anything about the forces that my legs are exerting, the forces or the work that my legs are generating. But since we have my mass and we have my initial and final velocities, the right-hand side of this equation we do have, and that's all we need to calculate the total work done. So let's do that. The final velocity gives us final kinetic energy. The initial velocity, that gives us the initial kinetic energy. The mass is 80. So this is 1.5 squared. Here's 5 squared. So that is negative 910 joules. So that is the total work done on me and my bicycle when I go from the base to the top of the bridge. That is the answer to part A. How much work have I done with the force I apply to the pedals? Jeez, I'm having so much trouble. Alright, so how much work is done by me? Well, if this is me on the bridge, at some random point on the bridge, there's going to be a normal force on me due to the bridge. I'm going to have my own weight, so the force of gravity exerted on me, and then something about F applied. You know, somehow my legs are generating a force and getting me to put in energy into the system. So how much work, well, put it this way, the total work is going to be equal to the work done by gravity plus the work done by me, my applied work from my legs or whatever. So what I'm looking for is W me. That's equal to the work total minus the work due to gravity, or the work that gravity does. This I just calculated, and this I can calculate easily. All I need to know is the force W that gravity applies on me, and then the displacement in that direction, which we were given. That was the 5.2 meters. So W gravity, since the displacement is actually in the upward direction, gravity is acting downwards, there's got to be a negative sign here. Negative mg, and then just for simplicity I'll call that y, mgy. So the answer to part B is going to be the negative 910 joules minus a negative mgy. So that's negative 910 plus 80 times 9.8 times 5.2. Times 9.8 times 5.2. This is 4,076.8 minus 910. 3,166.8 joules, or with significant figures, 3,170 joules. And so, yeah, my total work, the total work done on me is negative, which means I lost kinetic energy. And since that's my final velocity, yeah, everything's consistent. I would have lost way more energy if I hadn't done work on myself, if I hadn't pedaled. So that's how much work I had to apply in order to reach the top with a speed of 1.5 meters per second.